from the molten metal. When the flux cools, it forms a slag coating over the hot weld bead, providing more protection from the air. There isn't a magic welding rod that just does everything. You may find one that you like to use and that produces good results, but basically welding rods can be put into one of two groups: fast freeze or filler. The fast freeze rods, 6010 and 6011, have a strong arc force that provides deep penetration. A light flux coating makes the molten weld puddle clearly visible, and the weld puddle solidifies relatively quick, leaving distinct ripples in the finished weld bead. Filler rods, 6013, 7018, and 7024, don't penetrate as deep. They build up weld bead. A heavier flux coating covers the weld puddle, keeping it more fluid, allowing for a smoother finished weld bead. So where exactly do you use these different welding rods? 6010 is used strictly on DC plus and 6011 on AC or DC plus. The strong arc force of these rods can blow off rust and paint, making these a good choice for repairs or modifications where the metal can't be completely cleaned. Also, these rods are often used as a first pass to provide deep penetration or to fill gaps and fit-ups that are less than perfect, then covered with a filler rod. 6013 was actually designed for high-speed sheet metal welding on DC-, but these rods can also be used on AC or DC plus for general purpose welding and light fabrication. With stabilizers in the flux, 6013 is probably the easiest of all the rods to use, and it produces a smooth finished weld bead. 7018 is a low hydrogen rod with iron powder in the flux. It's generally used on DC plus, and an AC 7018 is also available. These produce the highest quality welds and were developed for situations where there's extreme stress on the weld joint. It can be used to weld some of the harder low alloy steels on cast steels, and when making heavier welds, the low hydrogen characteristics prevent the weld from cracking because of the expansion and contraction of the metal. Iron powder in the flux provides a high filler metal deposit rate, which means you can put more metal down faster. 7018 produces a smooth finished weld bead, but does require clean metal and a well-prepared joint. 7024 was used extensively in fabrication before wire feed. A heavy flux coating produces an extremely smooth weld bead, but these rods do require clean metal and a slightly higher amperage setting. 7024 can be used on DC plus or AC, and the 2 does indicate that this rod can only be used in the flat position. 6010, 6011, 6013, and 7018 are common rods and should be available everywhere. There are other welding rods, and they'll either be a fast freeze or a filler, with a different tensile strength, a slightly different flux covering, and usually designed for a specific purpose. Now, each of these rods has distinct characteristics, but there are some basic fundamentals that are common to all of arc welding. We'll start with the fast freeze type rods because the light flux allows you to see the molten weld puddle clearly. The fast freeze rods 6010 and 6011 are similar, and the same techniques can be used with either one. 6010 on DC plus might freeze or solidify a little quicker. 6011 with either AC or DC plus may be a little easier to use because of the stabilizers in the flux that help maintain the arc. Let's start by watching a weld, and I'll try and describe what to look for. After scratching the rod against the metal to make contact, the tip is held about 1/8 of an inch or 3 millimeters off the surface. This creates a gap for the arc to cross, and that's where the bright light comes from. While you're welding, don't watch the light. Look past it, through the smoke and sparks, and focus on the molten puddle of metal behind the rod. Welding takes a little practice, but it's not very difficult. Let's go through this step by step. First of all, you need to pay attention. This is ready to go. Anytime the tip of the rod touches the metal, it will arc. Okay, You want to get comfortable. Welding rods burn for about a minute, and it's a long ways out to the tip of the rod. So get comfortable and relax. Rest your arm on the table and use both hands on the stinger so you can be as steady as possible. When you're all set, either reach up and flip your hood down, or you can adjust the knobs on the side to flip the hood down with a nod. Starting the arc is like lighting a match. Drag the rod right against the metal. When it lights, bring the tip up and move back to the start. A scratch start gets the flux burning, forming the gases that purge air away from the molten puddle. To avoid leaving arc burns all over the metal, try to scratch right where you intend to weld. I usually hold the stinger with my thumb on the release lever. If the rod ever sticks, just open the stinger, then go back and break the rod off. If you're relighting a rod, the flux may be broken off a little at the tip. A scratch start will burn off that tip before you start depositing metal. Once the rod is burning, you need to start the puddle, giving the molten filler metal a little extra time to fuse to the base metal. This doesn't take long, only 2 or 3 little circles. Also, as the weld progresses, the base metal will heat up, causing the molten puddle to spread out. Start the puddle wide enough to keep the weld bead a uniform width. During the weld, the tip of the rod is held up off the metal. This is called the arc gap. Having control of this arc gap is one of the first and may be the most important thing you need to learn. As you're moving along to build weld bead, the rod is being consumed, so you also have to be moving in. And the whole time you need to maintain a constant, uniform gap between the tip of the rod and the base metal. If the tip of the rod is jammed right down on the metal, the arc doesn't have time to heat up the base metal. The weld bead kind of squirts out the back, not tying in well on the sides. If the arc gap is too long, the arc itself can jump around. Penetration will vary and you lose control of how the filler metal is deposited. Maintaining a constant arc gap is the first step to controlling the molten puddle and producing a uniform weld bead with consistent penetration. The better you learn to control that arc gap, the better you'll be able to weld. When the arc crosses the gap, it melts the base metal, forming a molten puddle. That arc stream also carries the filler metal from the rod into the puddle. This is a 6010 weld bead that I pulled out of quickly. The leading edge of the puddle was actually below the surface of the metal. The strong arc force of 6010 and 6011 penetrates deep into the base metal and pushes the molten puddle back, building up weld bead. While you're welding, watch the sides, right where the weld buildup meets the surface of the base metal. For building up weld bead, either a circular or zigzag motion is commonly used. With a circular motion, as you ease the puddle over, watch the edge. When you bring it across, watch the weld build up, then the other side, and just ease the puddle around and around. A side-to-side or zigzag will produce nearly the same weld bead. Watch the outside edge, the weld build up, and the outside edge every time you cross. Something you want to keep in mind is that molten metal will follow the heat. Whenever you move the puddle across, while you are adding filler metal from the rod, molten metal is also following from the side. If enough metal isn't put back there when you come around again, you'll leave under